All right, good morning. Welcome to Pre-Calculus. So we're going to talk about hyperbolas today. Okay, so hyperbolas are a little bit weird because they have a negative sign in them, but notice both of the variables are squared, but there's a negative sign between them. Okay, remember that this is the conic section that was formed by taking our cone. Okay, so in Greek, that's a cone, and making a vertical slice here. Okay, so these are always going to come in pairs. It's either going to look something like this and like this, or we might get a side-by-side sort of comparison like this or like this. Okay, the book does a better job than I do in explaining some of this stuff, so I would recommend looking through the book a little bit too, because you'll get my explanation, but mine's a little clunky because this is how I remember it rather than like the formal way of doing this. So I'm just going to warn you that the book is probably going to be a little bit, if you need a better or more formal definition, the book is probably going to be a better reference than like my weird explanation for this. Because when I learned all of this stuff, like we would tell each other stories about how this worked. And this is part of the story about how it works for me. Okay. Part of the thing is you have to figure out like which orientation do we have to deal with? Which one? Okay, the negative sign part, that's going to be the opposite. We're not going to pick that one. So whatever one is positive, so if the x or the y is positive, that's the orientation it's going to be. So in this case, my first example here, the orientation is positive y. So I know that the orientation of my hyperbola is going to be up and down. Okay, if the positive one was on the x, then it would be left, right. Okay, but since it's positive on the y, we're up and down. Okay, so they want to know, okay, what is the transverse axis and foci of the hyperbola on the y-axis? Same rules apply as the same thing as ellipses. So we're going to have a x minus h squared over, say, a squared minus or plus minus, okay, y minus k squared over b squared, okay, equals 1. Okay, I'll say minus plus. So I don't know which sign is going to be in front of them. That's why I swap them. Okay, they don't have to, like, y, x doesn't always have to be negative. Y doesn't always have to be negative. They're going to swap. Okay, but one of them will be positive. One of them will be negative. And the center is still going to be HK. Okay, so the center is HK, regardless of what's going on here. All right. And that's how we do this. So if I look at this and I say, okay, well, we're still going to say like method of intercepts. Okay, the method of intercepts. Okay, pretty much what this comes down to is we let the variables take turns being 0. Okay, x gets a turn to be 0, then we solve it, and then y gets a turn to be 0, and we solve for x. Okay, so in this problem that we're sitting here looking at, okay, we have y squared over 16 minus x squared over 17, delightful, equals 1. So we're going to set our x equal to 0, okay, using method of intercepts. So I have y squared minus 16 equals 1. So y squared over 16 equals 1. Y squared equals 16. Y equals plus or minus 4. Okay, that's what we do. All right, now if I take and swap them, okay, technically what we have, okay, set y equal to 0. We have negative x squared over 17 equals 1. So x squared equals negative 17, at which point we're going to say, oh, x equals plus or minus root 17i. Well, can we graph that when we're looking at x's and y's? Okay, if you took the trig part of this, then you're going to know that there is a coordinate system where we use real and imaginary. It's the complex plane. But we can't graph that. Like, yeah, but not for the rest of what we're doing. Okay, so we can graph it on a complex plane, but we don't use the complex plane in this chapter. And you know, your sister class, the people that didn't have the trigonometry part of things, don't know about this yet. So we're not going to worry about this. So because I end up with an imaginary number here, I know that this point doesn't actually appear on this graph. That's how I think about this. Your book is going to give you a slightly different explanation. Okay, so because it has an I in it, does not appear anywhere on, this is R2. Okay, this is the regular XY coordinate system graph that you've been used to since about, I don't know, fourth grade, fifth grade, sixth grade kind of a thing. Okay, and then we go ahead and find our vertices. Okay, and our vertices are where it says. Okay, so we're going to have our center is 0, 0, and the vertice is going to be 4 units in the y direction from the center. So my vertice is going to be 0, 4 and 0, negative 4. Okay. The transverse axis, okay, we don't really have to worry about the transverse axis because the transverse axis is on the y-axis. Okay, so we'll just go ahead and click that one. Okay. I'm sorry, the transverse axis of the foci, yeah, they're on the y-axis. Okay. So that's what we want. The foci, c squared is equal to a squared plus b squared. Okay, and these are the same exact things that is for ellipses. Okay, a squared and b squared are right here. Okay, so c squared is equal to 16 plus 17. So the foci are now outside of the curve rather than inside of the curve. Okay, with the ellipse, it was inside, so we had a squared minus b squared. So it brings the points, wherever the curve is, it brings it inside somewhere. With the pluses, it's going to bring it on the outside. Okay, so we're adding to it. Okay, so it should be x squared plus a squared plus b squared. So c squared is equal to 16 and 17. C squared, that should be 33. So c will be plus or minus root 33. From the center, along the regular axis, okay, along the axis that it exists on. Since we know that it's the y-axis, that's the transverse axis, we're going to know that it's going to be root 33, I'm sorry, x is 0, y is root 33, and then 0, negative root 33. Okay, and that's how we go ahead and figure out where the foci are. I have never needed the foci like in the middle of a calculus problem. So if they do ask you for the foci, have to use that in the calculus problem, I'd imagine that it's a homework problem that you would be allowed to go look this up, okay, and get that answer, okay, get that information so that you can go ahead and solve the problem. Doesn't happen all that often, so it's one of those things where it's like, when you need it, you can look it up. If the teacher really wants to make you memorize this, they'll tell you. But just like for the quiz, for us, I put in a little part where I said, by the way, the foci for an ellipse can be found with a squared plus b squared. Okay, I think that's in your quiz notes when I wrote the quiz, or your test notes when I wrote the test. Okay, because it's not something you need to memorize. It's not something you need to carry to your grave. Okay. Whereas the trig people, you do get formulas that you will memorize, for the people taking trig. Sum of angle formula, double angle formulas, sine squared plus cosine squared equals 1. Like you will when Alzheimer's comes for all of us, okay, you will forget your children's names before you forget sine squared plus cosine squared equals 1. Okay. So we're going to say, okay, there's a transverse axis is there. So we'll go ahead and check, make sure I know what transverse axis is. Okay. And then we're ready to go on. Okay, it's on the y-axis, so that's what we do there. All right, continue. Okay, and then we've got the same kind of A through D, A through N, A through Q sort of parts for all of this stuff, and I apologize for all of that. All these problems take a long time for no good reason, but that's just the way that they do this. Okay, so good luck with starting this, and welcome to Hyperbolas. These are a lot of fun.